Yeah, welcome back, the Global Genius. So today we're talking about debugging Python programs. We have been seeing how what errors are, how to handle errors, how to raise errors. Now today, let us take a look at when errors occur, how do we debug them? How do we try to find out what really happened? Okay, so when you say debugging, you want to really, because when it comes to errors, we call them bugs in computer programming. So you want to debug, you want to find out exactly what really happened, what is going on, why is your code not working as expected. Okay, so writing code is only one part of programming. Writing code is only just one part of programming. And finding and fixing problems in code is equally important. It's even as important. It's even as important as writing the code, or even more important, because definitely most times when you write code, you will actually have issues, you have errors. So how do you fix these problems? The process of fixing the problem is called debugging. You might have logical errors. Your code is not working as expected. What do? You have to debug it. You have to find a way. You have to find the problem and then fix it. A bug is any mistake in a program that causes incorrect behavior, crashes, or unexpected results. All right? A bug is any mistake in a program that causes incorrect behavior, crashes, or unexpected results. Examples are when a program crashes unexpectedly. We have seen that a lot. We have seen the programs that have errors. When we run them, they crash unexpectedly. When you have a wrong calculation, you might try to, what your intention might be to calculate the area of a square or a rectangle, but you were actually using the addition instead of multiplication. Missing outputs, okay. These are all right. So incorrect data storage, you can actually get incorrect data storage. These are causes of examples of bugs in your program. So debugging is the process of locating, understanding, and fixing these problems. They will definitely be there. There is no programmer that does not debug. That is why debugging is a big thing. All right. There must be errors. There will be bugs. Okay. You are not perfect. You're a human being. So what is a bug? A bug is an error. A bug is a flaw. A bug is a fault in a computer program. If something is not working correctly, that's a bug. If there's an error, if there's a problem, that's a bug. Okay? So look at the bug we have here. We are trying to calculate the area of this. And instead of using the doing length multiplied by width, we are doing addition here. So this is a logical error and is a bug. So our program is not going to work as expected. When you print this area, you're going to get 15. Meanwhile, you're supposed to get 50. The output is 15, but what you expected is 50. So this is a bug. So this is where you will not have to debug it to find out. You might not see this mistake out immediately, but over time, when you take a look at it, you will not be able to find out what you did wrong. All right. So this is a bug. It's a flaw. Your code, your logic is flawed. All right. Your logic is not correct in this case here. So the program runs successfully but produces the wrong answer. It will not crash, it will run successfully, all right, but it will produce a wrong answer. So this is a bug, all right. So if we go to, if we come here, if I say um, um, length is equal to 10, width is equal to 5, and then area is equal to um, length plus width instead of multiplied by width. If I go on and print area, what am I going to get? What would be the output? The output would be flawed. Okay. The output will not work as I expect. Look at it. But this is not the area. So you have to find a way to find out, oh, what did I do wrong? The program didn't crash. Everything worked correctly. Look at it. Everything is working correctly, but we are having a bug. Something is not working the way we expected. So what are the types of bugs? We already know some of them. So most of the errors that we know are bugs. Syntax bugs come from when you have syntax errors, or when you violate the syntax rules of Python. In this case, there is no colon. So this is a syntax rule, it's a syntax bug. All right, there is no colon here. There is a syntax rule. We have the runtime bugs that occur during execution of the program. So this occurs when the program is executing. 10 over 0, of course, is an error. It's a bug. You can't do this. Okay. So it's a bug. We also have logical bugs. The one we just did now is a logical bug because the program executes successfully but produces incorrect results. All right, that's what we just, in this case, now we have price to be 100, quantity to be 5. So when you say price minus quantity, you're supposed to be getting um, the total here. We expected to get 500. So we are trying to do 100 times 5. But in our logic here, we are doing 100 minus quantity, so as in price minus quantity, which is 100 minus 5. So if you expected to do multiplication, but you're doing addition, that will be a logical bug, okay? And you will not get the expected result. So why debugging is important? Without debugging, programs crash, all right? Users lose trust. If people don't trust your application, users lose trust. Data becomes inaccurate. Applications become unreliable. This is very, very bad. So professional developers, they spend a lot of time debugging and improving software quality. If these things are not working, all right, if these things are not working, your users will not be happy. Your program will be unreliable or to be inaccurate. So the debugging mindset. Now, when you see, like I have already told you, bugs are something that will always happen. So you need to wear the debugging mindset. All right. First of all, when something goes wrong, do not panic. Because if you panic, you might lose that concentration. Do not panic. All right. Don't randomly change your code. All right. Don't randomly change your code so that you don't even introduce another bug. All you have to do is to look at the error message, read the error message. We talked about this in the last class. Understand the problem. The error message will tell you what the problem is, where it's coming from, the line, the file, and everything. Reproduce the bug. Fix one thing at a time, all right, and then test again. All right. It will take some time. When you're debugging, it takes some time. Okay. So now you already know how to read Python tracebacks. Let me do something here. Let me cause an error here. If I say length divided by 0, and if I run this, we are going to get a traceback error. So we have this traceback, and with this traceback, you have to, this is the message you will use to use the error message to understand where the error is coming from. It is very, very clear. It says you're dividing by 0. So dividing by 0 is an error, and they are showing you what happened. And look at the particular line, the particular code that's causing it is being shown here. All right, so it is very simple. Don't panic unless or anyways, if it is not if it is logical error, of course you will not get this kind of information. All right, so um when Python encounters an exception, it displays the traceback. You already know this. That's what we have already done here. So this is the traceback. All right. It gives you all the information you need. All right. Components of the traceback. We have talked about this, but let us just reiterate it. So the file name, it tells you where the error occurred. Look at the file name. The file name is here. Look at the file. Look at the file error.py. Look at the file. All right. It gave you the error, the file name. It gave you the line number. All right. So it will give you the file name. The file name indicates where the error occurred, which file did the error occur. It will give you the line number. It will show you the exact location. Just like this one. This one shows us the exact location. Look at it. This is where the error occurred. And maybe if you, okay. It shows us the exact location. It shows us the exact location, okay? So, the error type tells us the kind of error. In our case, it's the division by 0. So it tells us the type of error that occurred. So to help you, it tells, look at it. Look at the type of error, division by 0. zero division error. Okay? It identifies the category of the problem. It helps you to understand the type of error. The error message is also there telling you the error message. So in the error type, you get the error message there. It provides additional information. The error, look at it. Here, it tells us that division by error is the issue. So we are trying to divide by error, so we shouldn't do that. So professional traceback reading strategy, because you have to learn how to do this. Okay, always start from the last line. Look at the last line in the traceback. The last line will give you a hint of what is really happening. Okay. Invalid value, error, invalid literal for int. This often immediately identifies the problem. It tells you where the problem is coming from. Then locate the file and the line number. So once you have gotten that, you locate the line, the file and the line number. So this is the file and this is the line number, line 5. So this is where the error, this is where we are getting the issue. Okay. So you can also do what we call print debugging. One of the simplest debugging techniques is to print, all right, your variables out. So you insert temporary print statements to inspect values, all right? So in this case now, we have price to be 100, quantity to be 5. We could just print the price to be sure, all right? Anyway, this is not an enough, this example is not enough for the printing thing because sometimes you might want to, in this case now, we, um, this is not this example is not just enough for printing, but when you actually start writing big code, you will be seeing enough of that. So in this case, we are printing the price. We want to be sure, all right, what the price is. We want to just be sure, all right, so that we will know. So you can print some variables so that it will help you to understand. Because you might be thinking that a variable is 100, meanwhile the variable is minus 100. That will not help you. So you can do more of printing in certain printing statements. All right. So you can use printing to actually get to understand the state of your variables while your program is running. I do that a lot. Tracking program flow. So you can actually check, all right, you can track the program flow. Here we are saying print step 1. All right, here where this is the first step. So it's the second step. So you're using this print statements here. This helps determine where execution stops. So okay, now maybe let's try this. Remember that the execution is going to stop here. So we might just print the first printing here could just be, we could call it variable initialization or yeah, variable. So this could just be our variables, all right? And then we can now do another print here. We can call it anything, we can call this one maybe area calculation. Okay, do you understand? And then we can now call this one um, area. So with this now, area printing. So with this now, we will know where this error occurs. So if I go on now to run this again, you will see that it printed out variables. Okay, and then it printed out area calculation, but it didn't get here. So you can now know that, oh, this thing happened around here. Immediately, it happened in the area calculation. So that is where it happened. So this will also help you. But you could give these things meaningful titles or something, variable. Okay, you can just give them very as in meaningful names. Okay, so you can see now that we were able to find out that, oh, this line, this particular step or this particular code ran very successfully and it came here, but now it didn't get here. I don't know if you understand. All right, so this helps to determine where the execution stop. You get to understand where the error occurred. So you can also debug your variables. You can look at your variables and print them. Okay, you can debug your variables. In this case, now we are having a name error. All right, score and bonus. Look at the name error. Look at the bonus here. The bonus says there is double S, but the one we are using is just single S. So that this will be name error. The bonus does not exist. this bonus here does not exist. So it's a name error. So what can you do? You can actually add debugging. You can print them. You may notice the typo when you are printing. So you can print them. Okay, you can print the variables out. There are a couple of ways you can actually do this. Okay, so instead of bonus, we're having bonus. So when you print them, you get to understand. Okay, so you can also use formatted statements. All right. You can use formatted statement to print out the variables. All right. You want to really understand, oh, okay, the name, what was the value? You want to understand the values of your variables. Instead of just printing them, you have to format them. I believe you know this formatting string. All right. I have taught you this. All right. So you can use this thing to print out the variable name and their value so that you will know exactly what is happening. Okay, these are very simple things to do. You're just using the print statement. So this makes the debugging very clearer. Now, you can also add the breakpoint function. When you include the breakpoint function, it will help you to inspect your variable. So if I go now and say, okay, so um, if I include breakpoints here, so this is where the error is happening. So if I include Okay, so let's assume now that I include the breakpoint here. All right. If I run this code, it would stop the program at that place. You can see the program stopped here after the variables. Do you understand? So we can manually do we have variable length. If I can print it. Okay, name error. So I didn't that's not the right this thing. Oh, sorry. Yes, variable there. You can see it gave me 10. I can also print width. It gave me width. So I can also maybe try, I don't have area. So if I try area, you can see because we have this breakpoint, I've not gotten to this area side. So it gives me error there. So you can use this breakpoint to stop execution at a particular point, and then you can now inspect the variables in that area. So, but if we get down here, we can close. Okay, so okay, I'll open a new one. So if I run this Python error.py. So because the breakpoint here didn't get to it because the error occurred. So you can use breakpoint and then just place so that you can actually stop execution there and then you can examine the variables you have. So when executed, Python will pause the execution at that particular line of code, all right? And then you can now, look at your variables, right? You can look at the variables that you have. So execution stop before calculating the result in this case where we have the breakpoint. Okay, it will stop. The result will not, the execution will not get to the result. So it will stop here. And then it allows you to inspect variables, just like you saw with me inspecting the length and the width. It examines the program state, its execution commands interactively, it executes commands interactively. You investigate the problem. There are just more you can do there. So in this case, now we have a breakpoint after the declaration, the initialization of name and age. But during debugging, you can now inspect name. You can, just like you saw me do length and weight, you can inspect the variables. So you can also use VS Code Debugger. Modern developers often use IDE to debug. One of the most popular is the VS Code Debugger. So features include there are breakpoints, there are variable inspections, there are cost tag. You're going to see everything now. Watch windows, step execution, and all of that. So how do you insert breakpoints in VS Code? Click on the left margin beside a line number. So look at if you want to use VS Code. Break debugging. So if you want to insert um, if you want the execution to stop at a point. So I can come here, look at it. If you take your mouse to the line to that line 5, any line at all, you can see that there is a red circle here. So if I click on it, it will create a breakpoint here. Now I have to go and say run or start debugging. If I click on it now, okay, which one do I want to use to debug? I'm selecting Python debug. Okay. Um, okay. So, what happened? Okay, so it's debugging. Now you can see now that it started running the program and it stopped at this place. I put a breakpoint. So this is the call stack window. You are going to see more of it. This is the call stack window. This is the breakpoint. This is the watch window. This is the variables. So this is what we are going to be taking a look at. So if you want to watch all the variables that you have, you will watch the local ones. The local ones is the length and the width. So you can see what is really happening. All right. If you want to go to global, you can see more. Do you understand? So this is where you will now inspect all your this. But let's continue. A red dot appears when you take your mouse beside left margin beside a line number, just like I did. So in this case now, if you take, I have shown you this, you just have to take your mouse to the left margin of a line number beside a line number, and you can click on it. So place a breakpoint on it, and then the program pauses before executing that line. So in VS Code, you open Run and Debug panel, you click Run and Debug, choose Python file, and then debugger starts. That's what I did exactly. Okay, so look at it. If you did not see me do it, just go back, take the video back and do so. You can see now that this program is running in debugging mode. Okay, take the video back to understand what I did. All right. So if you click on this, let's talk about some debugging controls. Continue. Now, in this case, now look at it. The program is paused, so but I can tell the program to continue. Right? Now, the program is paused. The execution is paused. It cannot continue until I tell. So if I say some of the controls, debugging controls you need to know is the continue control. So it runs until the next breakpoint. So if you have other breakpoints, it would once you say continue, it will run to the next breakpoint. But here we only have one, but you can have just many. You can keep plenty breakpoints, a lot of breakpoints, and then when you say continue, the program will run until it meets another breakpoint. So let's assume there is another breakpoint here. Okay. So let's assume there's another breakpoint here. Okay, it will run till that particular breakpoint. That's continue. Okay, so there's a shortcut F5. So if I don't want to, the shortcut for if I continue, see the continue, this button here, if I click on it, it will continue. All right, all right, or I can use F5. Anyone, so if I click on this, you can see it has come to the next breakpoint. All right. Had even I didn't have this breakpoint, it will just run till the program finishes. So it has come to the next breakpoint. Now you can go and check your variables again. We should have, okay, area is not yet declared. So if I click on continue again, there is no other breakpoint here. All right. But okay, if I try this one, another breakpoint here, if I click on continue, of course, we are going to have that error. All right, we are going to have that error, but it's telling us that length is 10 here. So if I click on this, of course, there is an error. So you can see this is even better. It's telling us exactly what really happened and we are here. Do you understand? You get to understand what really happened. Okay. So you can stop by clicking on this one, or you can do Shift F5. So I click on it to stop the debugging. The debugging has stopped. Okay, so another one is step over. So when you have it's execute the current line and move to the next. So the shortcut is F10. It will step over, go, it means execute the current line and move to the next line. So if I go back again, let's try step over. Okay, so if I have this breakpoint here and I click on run and debug, okay. So step over, look at the icon, the step over. It means go to the next line. If I click on this, it will go to the next line. So if I want to inspect this program line by line, I will just be using the step over. Do you understand? I'll be using the step over or F10. So it will go to the next line, to the next line, to the next line. Another one that we have is step into. So if there is any function, if Hadebe will have a function, it will enter inside of the function. So if you want it to enter inside of a function, you use the step into. So, but here now we don't have any function. So if I try step into, there is no function. All right. It's just as if we are doing step over because there is no function. All right. So, but let me show you, let me stop debugging and let me create a function. Okay. Maybe I could just, um, okay, let me create a function. I could say def area. This. So I will just say, uh, I could just say return. I could just say return length, um, length multiplied by width. Okay. Length multiplied by width. Okay. So after this, I will just have result is equal to, here I am calling the function, right? Okay, so is everything okay? I believe so. Then I am printing the result here. So I just changed my code a little bit. So if I go on to run debug, okay, there is no breakpoint here. Look at, there is no breakpoint. So everything will just run. There is no breakpoint. So you can see there's no breakpoint. Okay, there's a breakpoint. Sorry, there's a breakpoint. So I can do step over to the next line. I can do step over to the next line again. Then I can do step over again. Look at it. It will actually get jump from next line. Now we are in the function that's in this line now, but I want to get into, if I want to get into this function to see what is happening inside the function, I will now use step into. If I say step into, you can see it has gone inside of the function. It has gone inside of the function now. All right. So that is step into. You use step into to get, if you get into a function, if you want to get into a function, you step into. All right. So the shortcut is 11. We also have step out. So if I want to step out of the function, what do I do? If I continue to say step over, okay, so if I do step into, okay, so all right, let's just start afresh. I will run on debug. Okay, I can say continue. If I say continue, there is no other breakpoint to just run. If I say continue, the program will the program has executed because I said continue. So there's no other breakpoint for to stop it. So it will run to the end of the program or it will run to the next breakpoint. But since we don't have another breakpoint, so it runs till the end of the program. So here I can also do step over, right? And when I get to a function, I can do step into. I'm inside of it. If I want to do step out, I click on step out. It gets out of the function, and then we can continue, and then continue. Do you understand? Okay. So. It exists the current function. The shortcut is Shift F11. So examples of step into, we have already done this already. You have seen me I created a function. We stepped into a function. We stepped out of a function, and that is it. So it allows you to inspect execution inside a function. So when you get inside a function, you can now execute. You can now inspect um, what is going on inside of the function. Okay. So how do you inspect variables? So when you're in debugging mode with Visual Studio Code, it shows variable values. I showed that to you. So this will display the values of. So look at it here. If we go run debug, as we are stepping over or we are stepping into or we are stepping out, so you'll be seeing the variables So far, so good. We don't have any variable declared here because we are just here. This variable have not been declared. But if you do step over, you can see this variable has been created, length has been created, but width have not been created. If I do another step over, you can see width has been created. So this is how you watch your variables. And if you take your mouse, you can see, look at it. It's giving us the values here already. Look at the values here. So you can see that debugging is very, very so. Here, we now have the function variable, which is area. All right. We also have special variables. These are the special variables that come with the function. Okay, so you can inspect things here. Okay, you can inspect things here. When I step over again, we now have result to be 50. So you can see that this is where you can also check. Okay, is my result what I expect it to be or not? So this is where you inspect variables. Okay. So no print statements required. You don't need to use print statement. This is just the best. Okay. So you can also take a look at the watch window. It allows monitoring specific variables. So we can watch our watch. Where's our watch window? This is our watch window here. Uh-huh. Okay, there's nothing in our watch window. There's nothing in our watch window. Okay, but our watch window allows us to watch. In this case, now we have balance. Whenever balance changes, the debugger updates its value automatically. So okay, so let's start afresh. Let's start afresh. Okay, so if I step, okay, nothing is in the watch window right now. Nothing is in the watch window. Expression to watch. If I say area. You can see, okay, I can add, I can say I want to watch length change, or I want to watch result change. There is no result already here, but in case we are doing, had it been we had, okay, so let's say, let's stop debugging. So let's stop debugging. Let us create result here and initialize it to 0. So when we get here, the result is going to change. So if I run debug now, okay, all of them, you can see that all of them are still name error because they have not been declared. So here you can see now rest have changed because I'm watching it and it has changed. If you want all the variables you want to watch, you can actually come and add them. You can also add length. In case you want to watch length as it is changing. All right. Do you understand? You can also add width if you want to. So I keep on going. I keep on going. I keep on going. Now you can see that rest has changed and it updates automatically. So that is it. So this is very beautiful using the VS Code debugger. You can also take a look at the call stack. The call stack shows you the functions that the sequence of function calls, how the functions are being called. Okay, so for us to really enjoy this call stack, let us have multiple functions here. So I would going to have def add. And then I will just say return A plus B. Okay, so my bad. A and B. And then I could also have another def. I could say sum. And I'll have A and B. Sorry. And I could say return A minus B. Then I could also have another function. I want to have another function. This function is not going to, this function we'll call it add underscore sub. All right. It's going to call the two functions. It will call add. Okay, so let me have this. It could call add, and then it will call add. It will also call sub. No, sorry, sum. Okay, so this is supposed to be sub, not sum. subtract. So I'll call it sub, and I'm passing A and B. Now let us go and watch. So if this is what I'm going to do now, I'm going to, I will call add sub. I will call add sub and I'll give it 3 and 4. So let us go and inspect the call stack. Look at this particular function is calling these two functions. So let us go and inspect them, how they are being called. So the call stack, but this is somehow advanced, but it's okay. In case you don't understand it, don't panic. So this is the call stack. All right. So we are okay. Do we have a breakpoint here? There is a breakpoint here. So if I do step into, it goes into the function and you can see the call stack. So I don't know, this is somehow um, bigger than you right now, but call stack shows us how the functions are being called. You can see now that as sub has been called. All right. Now we stepped into it. If I go again, if I do step into again, where are we going to? We are going to the add function. Look at it. We're in the add function, and this add function has been added to the call stack, so it has been called. We can now do step over to step out, or maybe step over. All right. Then we can do step over again. We go to, and you can see now the add function has been removed because it has been called and returned. Like I said, this can be big. This is beyond your scope right now. Yeah, this is beyond your scope right now. This is beyond your scope right now. So we can also do step into. All right, you can see now it has added the function in the call stack. But once we do step out, it removes it. But you can see now that the add sub is still in progress. But the moment we actually do this, all right, you can see it has been removed. All right, so and our program will end. So, but it's okay. This is can be too much for you. But this the construct shows you the sequence of function calls, how the functions are being called. All right, shows you that's exactly what you have seen. But don't worry, this is beyond your scope for now. Okay, so now, you can debugging logical errors. Logical errors are often the hardest to find when you have something like this. You want the average, but you're doing the sum. You're doing sum instead of the average. Average should be sum divided by the number of items that we have. So, but we are going to get something wrong. So, how do you debug? The expected result is 90, but you're getting 270. Use debugging. Use print statements. All right, use print statements. Okay, and then you will see that you're doing something very wrong and you have to correct it. So debugging loops if you have some loops, you can actually use the print statement to debug to find out exactly what you are expecting. All right, whether it is what you got is check whether if it's what's expected. If results are unexpected, then you use this formatted print statement to actually check exactly what the I is. So basically, when you have logical error, you'll be using the print statement a lot. All right. So trace the loop behavior and all these things would. So if you want to debug functions, um, you were expecting, you can see this is wrong. You were expecting addition here, but you're doing subtraction. So you can actually inspect, use the print statement, or you can use step through with your VS Code debugger. Step into and go and see what is really happening inside of the function. So read the error message, most important step, reproduce the problem, make sure that the bug occurs consistently, isolate the problem, reduce the code, any code that is causing the problem, reduce it, log. You can comment it out to see exactly what is happening without the function, without the line. Okay? Yeah. So check the recent changes. Many bugs come from recent modifications. Verify your assumptions. Don't assume variables contain expected values. So verify them, debug them, print them, inspect them, verify them. Okay? So there is this technique called the rubber duck debugging. A form of debugging technique is explain your code line by line. Go back to your code, explain it line by line. When you're trying to explain it line by line, you're going to find out where the problem is. So if instead of you to do addition, you're doing subtraction. When you go to explain your code line by line, you're going to find out that you're doing addition, subtraction instead of addition. So a robot dog, a friend, a colleague, explain your code to somebody. Often the mistake becomes very obvious. You can even try to explain it to yourself. Okay. All right. So let's take a look at some real world debugging example. We have this function that is returning price plus quantity. We are supposed to calculate the total. All right. Price plus quantity. Is it the total? It will print 105. But is that the total? All right. Now, we expected 500 because the total money we are supposed to make from this is price times quantity. And we, instead of doing multiplication, we are doing addition. So if you explain this line of code to yourself or to somebody, you find out that the error is here. What are you trying to calculate? We are trying to calculate maybe the price. We have some quantity of items and we want to check how much are we going to make from selling of them. So it should be the price times quantity. So it should be times, not addition. So you can see that I'm trying to explain this code, what this code is doing, and then I was able to find out that, oh, I'm supposed to do multiplication, not addition. And the expected result is 500, and we were getting 105. Okay, so print the price, print the quantity, inspect review. Inspection reviews that return price plus quantity is wrong. It should be this. So when you try to explain your code line by line, all right, you get to understand what is the problem and you can fix it by just doing this. Okay. So thank you very much. And if you have any difficulty, if you face any difficulty, please reach out. Reach out. Thank you very much. And I'll see you in the next class.